Hello. Today we are doing supplemental problems related to 4.5, which is exponential, and logarithmic equations. Okay, and we're going to be doing several examples here, so let's take a look at number 16 out of your book. It is 3 to the x over 14 equals 0.1. Now remember that one of our first steps is going to be to isolate the exponential and the equation. And we've already done that. So our next step is going to be to take a log on both sides. And since the base of the exponential is 3, we want to choose the base of the log to also be a 3. Okay, now if you remember by property 3, as long as the base of the log and the argument are the same number, which in this case is 3, then the exponent is what remains. It has that cancellation property. Okay, so then what we want to do is multiply both sides by 14. And finally we arrive at x equal, let's erase that. Okay, and finally we arrive at x equals 14 log base 3 of 0.1. Alright. For our next problem, we want to do number 26 out of the book. That is 10 over 1 plus e to the negative x equals 2. Okay, well, this one's going to be a little trickier because our exponential is not isolated. So, we can do a couple of different things, but probably the one that you're going to be most comfortable with is this idea of cross multiplication. So remember, with cross multiplication, we can multiply in that sort of x symbol. 10 times 1 will equal what's on the bottom here times 2. Now we can simplify and we get, whoops, not 20. That's not what 10 times 1 is. 10 times 1 is 10. And remember, we can do the distributive property. So 1 times 2 is 2, and e to the negative x times 2 is e to the negative x times 2 is 2e to the negative x. Then what we need to do is again isolate the exponential term, so we can subtract 2 on both sides. And we see that this and this add up to just a 0. So we have 2e to the negative x remaining. Now what we want to do is divide both sides by 2. So 8 over 2 is 2e to the negative x over 2. And we get that, that cancellation property. This goes away. So let's move this over. Just a little bit, and we get that 4 equals e to the negative x. Okay. Looks terrible. Having a hard time drawing today, guys. Okay, now we've isolated the exponential term, so we can take a log of both sides. But since we have base e, we take log base e. But we don't write log base e, right? This is kind of not normal for us. Instead, we want to write the natural log. And so again, by that property 3, the base, so like you have this base and the argument match. So what's left on this side is negative x. And if we want to get x by itself, we need to divide by a negative 1. Leaving x is negative natural log 4. Now, for our next problem, it's actually a little simpler, but it just looks kind of terrible. And it is 1.00625 to the 12t equals 2. Now, I know that looks pretty horrible, but it turns out this is not so bad. So if we're isolating the exponential term, we notice that we've actually already done that, so we need to take a log. But, we normally use this number as the base. And in this case, that's no different. It just happens to be a really obscure base. So again, we have the fact we have this base, and this is the base of the exponent. So property 3 tells us that 12t equals log base 1.00625 of 2. And then we want to isolate t, so we divide by 12. So t, if we pull the 12 up front as a 1/12, that's probably a little cleaner to look at. Let's be very careful how we write this. Don't want the 0 to look like a 6. And that's our answer. Doesn't look super pretty, but that doesn't mean it's not the right answer. Now let's look at one of the quadratic ones that everyone seemed to not like. So number 36, we see that we have x squared e to the x plus x e to the x minus e to the x equals 0. So if we're solving this, the first thing I notice is that I have an e to the x, an e to the x, and an e to the x. So I'm just going to go ahead and factor out that exponential and have x squared plus x minus 1 equals 0. Now what we would love to do is factor. So we can, we would love to just be able to factor this thing, and that would make our lives so much easier. Well, too bad. So what we've got to do is we've got to split this up into two cases. So case 1, e to the x equals 0. So if we were going to solve this, what I would say is, okay, well, the natural log of e to the x is the natural log of 0, and x should be the natural log of 0. But remember, the domain of the natural log is only positive numbers, so we cannot take the natural log of 0. So there is no solution for that case. So then we have to say, okay, well, Let's put some headlines here. We have to say, okay, well, where is x squared plus x minus 1? How do I figure that out? Well, let's go back in our memory. If we have something that looks like this and we want to figure out how it equals 0, we have two options. One is completing the square, which most people would probably rather cut off a finger than do. But the second one, and probably a little more palatable one, is the quadratic formula. And remember that the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. For those of you who probably had an exceptionally eccentric teacher, you probably learned the pop goes the weasel way, which I will shamefully do now, which, you have the negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, now that's stuck in your memory forever. So, yeah, you'll be able to remember it. Now nursery rhymes will be terrible for you. Okay, so using this, we see that a is 1, b is also 1, because that's the coefficient for that one, and c is negative 1. So using that, we can say x equals negative 1 plus or minus the square root of 1 squared minus 4, 1, negative 1, all over 2 times 1, which then equals negative 1 plus or minus 1. We see that negative 4 times 1 is negative 4 times a negative 1 becomes a positive 4. Ugh, that looks terrible. Becomes a positive 4 all over 2 times 1, which is 2. Of course, 1 plus 4 is 5. And we can do x. So your answer then becomes this. Which again isn't pretty, but that doesn't mean that it's not the right answer. Okay, now we want to work number 40, which is the logarithmic equations. I think you guys liked the logarithmic equations okay. I think it was really just the quadratics that really got on your nerves. So we have log of x minus 4 equals 3. Well, to solve this, what I would do first and foremost is rewrite this with the base 10, just because that's going to be a little more helpful. And if we remember, the log base a of x equals y if and only if a to the y equals x. So we see a matches to 10, y matches to 3, and x matches to x minus 4. So we can say 10 cubed equals x minus 4. Okay, for this problem, which is number 50, we have log base 3 of x plus 15 minus log base 3 of x minus 1 equals 2. So this one's a little more complicated, but we'll get there just step by step. So the first thing that we want to do is use the quotient rule. I see that I have a log minus a log. So If we apply the quotient rule, we arrive at log base 3 of x plus 15 over x minus 1 equals 2. So we now have a single log, and we can use the exponential form of the logarithm. So log a of x equals y if and only if a to the y equals x. So we see that a is 3, y is 2, and x is this fraction. So we can now rewrite that. We can say 3 squared equals x plus 15 over x minus 1, which we can rewrite as 9 equals x plus 15 over x minus 1, which we can again then write as 9 over 1 equals x plus 15 over x minus 1. We do this because what we really want to do is cross multiply. So remember, we can take this times this equals this times this, or think of that as the x while we use that term cross multiply. So from there, we can use the distributive property. 9 times x is 9x, and 9 times negative 1 is negative 9. And 1 times x plus 15, of course, is just x plus 15. And now you remember that we want to get the x's on one side and the not x's on the other side. So if we subtract an x from both sides, 9x minus x is 8x. X minus x is 0, leaving a 15. Then we want to get the not x's, or get x by itself, maybe is a better way to say it. So to get rid of that 9 on the left, we have to add 9 to both sides, leaving an 8x, and then 15 plus 9 is 24. Finally, if we divide both sides by 8, we have that cancellation property, so x is 3. So again, it's not that we're doing a whole lot of work. If you think about it, in this step right here, all we did was apply the quotient rule. And then to get to this step, we used the converting to exponential form. So 2 things you should be reasonably comfortable with. Then once we got here, this was just writing it as this is just solving an equation. So 3 squared becomes 9, which we can write as a fraction. Now cross multiplication you should all be fairly comfortable with. And once we get to this point, now this is just, this is college algebra, if not a little less. This is like a pre-algebra almost skill. So yes, it's a lot of steps, but again, it's all manageable steps. Okay, as a final example, sort of like a cherry on top, I guess, we have number 54, which is the natural log of x minus 1 equals the natural log natural log of x minus 1 plus the natural log of x plus 2 equals 1. So now we're not dealing with logs with integer bases, we have the natural log here. But the process is still the same, even though you're going to probably hate the answer. We have 2 logs, so we can use the product rule here. To combine them into a single log. And instead of writing that way as the natural log, we're going to write it as the log of base e. just so that converting to exponential form will be a little more straightforward. So again, remember log base A of x equals y if and only if a to the y equals x. So a matches to e, y matches to 1, and x matches to this product here. So then we have e to the 1 equals x minus 1, x plus 2. Well, e to the 1 is just e, and then we have x squared plus x minus 2. And so you probably are wondering, well, how in the world are we going to do this? Well, the answer is we're going to get everything on one side and have 0 on the other. So if we subtract e from both sides, we get 0 equals x squared plus x minus 2 plus e. And so the question is, why did I write it that way? Well, hopefully it'll become apparent. So 2 plus e, you're probably wondering what this is. Well, 2 plus e is just a number, right? If I had said 2 plus pi, that would just be a number. It would be, 5.14159265 blah, 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 blah. Well, 2 plus e is just going to be 4.718281828, blah, 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 blah. It's just a number. It's not anything fancy. So we can still use the good old-fashioned quadratic formula with a equals 1, b equals 1, and c equals negative 2 plus e. Okay. So that's a little crazy looking, but again, we have x is, probably should block this off, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we just want to substitute in those values. We say, okay, x equals negative 1 plus or minus 1 squared minus 4, 1, negative 2 plus e, all over 2 times 1. So that's negative 1 plus or minus 1. So we notice that we have a negative here and a negative here. So that's going to cancel and become a plus 4 times 2 plus e all over 2, which is negative 1 plus or minus the square root of 1 plus 4 times 2 is 8. 4 times e is 4e all over 2. So then we have negative 1 plus or minus 1 plus 8 is 9 plus 4e over 2. So your answer is going to be negative 1 plus the square root of 9 plus 4e over 2, or negative 1 minus the square root of 9 plus 4e over 2, at least theoretically. Now, what we see on this answer is that this thing is always negative, right? Because I've got a negative here and a negative here. So if I try to plug that into this thing right here, I'm going to get a negative answer. So this answer is actually out. Which means that what we can do is erase that. And this is our only answer. Alright, well, that wraps it up. I hope that you can use these to become sufficiently prepared for your exam. I apologize for the late posting. There's been a series of technical difficulties. So, good luck.